Coordinator for UW Discovery Farms. I'm going to be talking to you today about how to minimize manure nutrient transport to tile systems. So Discovery Farms is a farmer-led water quality research and education program. We conduct soil and water research on real working farms across the state. We then bring the results of that research back out to the farming community through field days, workshops, conferences, and publications. We utilize these 365-day-a-year monitoring systems to measure snowmelt and runoff. We keep track of all sorts of weather and soil information, and we are recording all of the water flow that comes off of the field and taking samples to look at soil loss as well as nutrients such as nitrogen and phosphorus. A lot of what we do is edge of field monitoring, but we also do I have a large tile drainage program going on right now in the Northeast, which is what I work on. We also do some stream monitoring as well. But the edge of the field and the subsurface tile drainage is the bulk of our work. So tile drainage has tremendous agronomic benefits. Tile improves drainage and root zone aeration, which increases crop yields. Tiles drain excess soil moisture, making it easier to access fields when you need to get in them, meaning that you can plant on time and not cause compaction by driving on wet soils. Tile actually reduces surface runoff and soil erosion by making room in the soil to absorb more rainwater. And tile helps raise the soil temperatures faster in the spring because dry soils warm faster than wet soil. That leads to earlier planting times. So tile has all these tremendous benefits, but those benefits come at a cost. Tile is what we call a direct conduit to surface water. It's quite literally a pipe leading from the field out to a ditch or stream. And so without proper management, we run a high risk of losing manure and nutrients through the tiles and impairing our waters. So we have to be mindful about how, when, and where we apply manure to tiled fields to maximize those agronomic benefits while minimizing the environmental risks. So I'm going to share with you today some tips for maintaining and managing tile drain lands to minimize that risk of manure and nutrient loss to tiles. First things first, we need to understand how tile works and be able to locate tile features. Tile is a system of underground pipes that move water by gravity to an outlet. Know where your outlets are and if you have surface inlets, and try to know where your tiles themselves are actually located. Some tile was installed generations ago and the current operators don't even know it exists, or maybe you picked up some rental land and aren't aware of exactly where the tiles are located. A good place to start is on Google Earth. This satellite image you see here is actually from Toronto County, and clearly you can see the location of tile drains, and this is not a one-off field. You can see this on fields all across the state. You really need to locate those tile outlets. If they're not marked, they can be pretty difficult to locate. A lot of times they're lost in a mat of reed canary grass or tangled in the brush. A good way to find them is to go out in the springtime, late April, early May, when tiles are flowing at their peaks, and walk quietly along stream and ditch banks. You can actually listen and hear the water trickling out of the outlet. Once you know that you actually have tile and you found those outlets and inlets, you can work to maintain those tiles. Tile is pretty low maintenance, but it does require some. Once a year, you should go out and check your tile outlets for blockages and jump on the four-wheeler and run around and check the laterals and mains for blowouts. Blowouts are a huge source of soil loss through the tiles, and the voids that they create are a direct pathway for manure and nutrients to enter tile. Blowouts start out as a weak point in the tile. When we have high pressure flows, that creates a rupture causing water to squirt out into the soil, which is then flushed out into the drain. Eventually, enough soil is flushed out from above the rupture to create a blowout that reaches to the soil surface. This is when you'll actually be able to find them. Blowouts often are very small holes, which can be difficult to find, except during high water flows when water might be flowing out of them, or when you can see surface water flowing down into the hole. So the picture on the bottom left, that's water getting sucked down into a hole, or conversely on the right, that's actually water bubbling up out of the ground. The hydraulic head pressure of the way that this is situated in the land, the water is actually gurgling out like an artesian well. Blowouts can be caused by a variety of things. Blowouts often occur in old clay or concrete tile systems. These systems are old and they've just reached the end of their lifespans, and those clay and concrete tiles are starting to actually just break apart. Blowouts can also be caused by inadequate venting. Think about your soda bottle. If you tip it upside down, it's going to go glug, glug, glug. That's because there's back pressure created because water is trying to, or the air is trying to get inside to equalize that pressure. So you have a vent at the high point in your tile system that can equalize that pressure and reduce it. Oftentimes, old systems are expanded or added onto without having adequately sized mains or submains. So you might have 40 acres that was tiled 10 years ago, and now you want to add another 40 acres into that existing system. But is that main or submain large enough to take on that extra water? If not, you're going to get increases in pressure, and that can lead to blowouts. Blocked outlets lead to pressure buildup, which causes blowouts. In modern plastic systems, oftentimes those weak points are found at joint connections or junctions from the laterals to the main or between old and new tile lines. So you need to be careful when you're putting in those tile systems that everything is connected properly. And of course, if you hit a tile with a chisel plow or a deep ripper or something, you're going to cause a blowout as well. So be careful around shallow tiles. So I've got a quick little video here. Don't mind the intro. The
Hello,
main
this
thing
is
is
Aaron
the
Pape,
pictures and
Tile Drainage
videos.
Education Coordinator for Discovery
Give you
Farms,
a few
Wisconsin.
examples of what these
As part of the
tile
regular maintenance
blowouts actually
regime
look
for
like.
your tile systems, you should inspect
So
your
here
fields for
is
tile
a
blowouts.
hayfield that I was in
Blowouts are
Shawano County
easiest to
last
identify
year.
in the
That's
spring
from
when
a
tile
picture from
flows are
another field.
generally at their
But this
highest.
one, there was water
Things to
flowing
look for
across the
include water
surface,
running over the surface and
and
then
lo and
disappearing
behold,
into the
it
ground.
goes down. I mean, it looks
Sunken
like a gopher
spots, and
hole, but
oftentimes
that led
small
straight
holes
down
leading
into
directly
the
down to the
tile line.
tile. Sometimes you can even hear a
Oftentimes,
sucking
you're really
sound
only
as
looking
water is
for
drawn into the blowout.
small little holes or maybe
It
a
is
sunken
important to
spot in a
repair these
field where
blowouts as
that
soon as
soil is starting to
possible,
fall down
as
into
these are a
that
direct
void.
conduit for soil, nutrients, and other
Springtime,
potential
when tiles
contaminants
are
to reach
flowing
the
at their peaks
tiles
or
and
when we got
flow out to
surface
surface
water
waters.
on the
For
surface,
more information
those
on
are
tile
good times to be
blowouts
able
and
to
other
actually
tile-related
locate
topics,
those
visit
blowouts. Mentioned before blockages. This is a tile that we monitor in Manitowoc County that every once in a while a muskrat or something decides that it's a nice place to go stash some grass and brush, and it's clogged up. Putting a rodent guard on here can really help to keep the vegetation from getting stuck in there by rodents or have muskrats or raccoons or something crawl up there and die. Those blockages right at the outlet are a perfect way for a blowout to start forming. Ice dams, even at the outlet, can lead to blowout, can cause blowout pressures. We experienced this firsthand at one of the tiles that we monitor. Came out to check the tiles one day. We have an ag drain at this site, and there was water pouring out of the side of the hole. Lift up the cover, and there's all this water coming up right up to the surface. It shouldn't be there. That ice dam that you saw before, that was part of that PVC pipe you see in the bottom corner there. And where the PVC pipe meets the actual tile pipe, there was water bubbling up out of the ground. So if we didn't have that ag drain there to relieve some of the pressure, I think that probably would have been a prime spot for a blowout to be forming. When you're fixing blowouts, it's important to fix the underlying problem also. Why did this blowout occur? Blowouts are often a symptom of a larger problem, such as an improperly sized main or an old failing clay or concrete system. Fix the problem, or you'll be chasing blowouts across the field. Find out if you're part of a drainage district. If you are, it's a good idea to let your drainage board know that you're doing tile repairs. They might even have some assistance available for you. When you're doing any sort of tile work, you need to be aware of wetland rules. The first thing you should do is talk to your local NRCS office and fill out a form called AD 1026. Then show them on the map where you're going to be digging up and replacing the tile, and they should be able to let you know relatively quickly if you are in a wetland area or not. If the land is considered prior converted, NRCS and Army Corps of Engineers will give you the green light. However, DNR may have an issue if you're digging in what they consider a wetland area. Talk with DNR and they will work with you. Generally, as long as you are repairing that tile in kind, that is replacing the same size pipe at the same depth, they'll be okay with it. Enlarging or expanding systems will require more extensive review. There's always issues when doing any sort of excavating or filling in a wetland. And so make sure that you talk to both NRCS and DNR because they are not always on the same page. And as always, don't impact any adjacent wetlands whenever you're doing any sort of tile work or repair. So that was a lot of the maintenance side of tile. And now let's get into the actual management. How do we manage those tiles to minimize those that risk that tile poses to surface water? One of the most important things you need to do is to assess soil conditions prior to liquid manure applications. So both high and low soil conditions are problematic for liquid manure. With high moisture, tiles are flowing, meaning that the liquids are actively being carried through the tiles. So if you add more water to it, you're only going to ask for that liquid manure to be going out the outlet. Conversely, in very dry conditions, soil cracks are actually a pathway for liquid manure to travel down to the tiles. So like most things in life, it's a happy medium that we want. Not too wet, but not too dry. It's also important to check the forecast. If rain is predicted in the next couple of days, you should not spread. You're really just asking for it to be washed into the tiles. Don't forget that when you apply liquid manure, you're increasing the soil moisture level. A 6,500 gallon liquid manure application is equivalent to the same amount of moisture that's delivered in a 1/4 inch rain. And your manure isn't coming in a nice, slow, steady trickle. It's going all on at once. 12,000 gallons, that's almost 1/2 inch. So the question you need to ask yourself is your soil going to be able to take that much additional moisture without triggering a tile flow? If there's two things you leave with today, it's these two things. Always make sure that you're not applying liquid manure to excessively wet or excessively dry soils, and make sure it's not going to rain in the next couple of days after you apply. Here is an example of what can happen when manure is applied to a field with wet soils followed by rain. Manure was injected on October 25th to an already wet field. On October 28th, it rained less than a 1/4 inch, but it was enough to cause the already moisture-laden soil to trigger a tile flow. The phosphorus concentration in that following sample was 30 times the average concentration for that particular site. Along with that, we need to monitor the outlets when applying liquid manure before, during, and after. So if tiles are flowing before applications, you should not spread on that field. If tiles start flowing during an application, stop immediately and check to see if it's manure that's coming out. And come back after a day or two to make sure that tiles are not flowing after you apply manure as well. Check for brown water, quite honestly. Restrict tile discharge prior to manure applications if you can. This isn't feasible for a lot of fields, but if you do have a water level control structure like an agri-drain installed, you can insert the stop logs to stop the water flow prior to application, and then you can remove them after a couple of days when the risk of manure runoff is past. We need to take extra precautions when applying liquid manure to land under no-till or perennial crops like alfalfa. These soils have well-developed preferential flow paths. Stuff like earthworm burrows, root channels, those big shrinkage cracks we talked about before, and just good structural porosity in general, from not being tilled for many years. This is great for water drainage, good for infiltration, but it's problematic for manure applications. All those burrows and channels and preferential flow paths are direct pathways from the soil surface down to the tiles. So this connectivity between the soil surface and tile lines is dramatically demonstrated with a tile smoking. So tile smoking is where you use a machine to blow smoke up the outlet and then see where it comes out in the soil out in the field. So this picture shows smoke coming up from one of those shrinkage cracks that's directly above a tile line. These little chimneys that you see in this picture are actually little earthworm holes that the smoke is coming up out of. So in this spot, 500 gallons of water was dumped over a tile line the night before the tile was smoked. It swelled up those shrinkage cracks, but the worms cleaned out their middens to let the water through, and so the wormholes were even more obvious in this area. Worm concentrations are higher above the tile lines than between the tile lines. Worms like to live in a nice, well-drained soil, and so this again illustrates the need for a happy medium for soil moisture. Soils need to be moist enough to have those swell cracks closed up, but dry enough so that the wormholes are closed and they're not going to initiate flow with additional liquid manure being applied. So the best way to handle this is through low rate applications or split applications. A low rate can be applied to swell those cracks shut and then come back in a day or two with a higher rate to finish the job. 2 passes at 6,000 gallons are going to be much lower risk than one pass at 12,000 gallons. I understand it's additional trip across the field, additional expense, but we're talking about managing these high risk fields, and that's the best way to manage risk, is to use low rates and split over time. Tiles are very efficient at removing water. Until the tiles reach their maximum flow capacity, they're draining just about all the excess moisture from a field, at which point surface runoff begins. That increase in tile flow begins only minutes after rainfall. Again, this illustrates the connectivity of the soil surface and the tile lines. Liquid manure can move through the soil to the tiles just like rain, and so if too much manure is applied relative to soil moisture conditions, we can get manure flowing through the tiles. We need to take extra precaution when we're applying manure and fertilizer in fields that have surface inlets. Surface inlets are used to drain closed depressions in fields. These surface inlets are direct conduits into the tile system, and so manure and nutrient applications made near surface inlets should only be conducted when there's no risk of precipitation and at rates well within reason. It's really a good idea to leave a buffer of at least 50 feet around those inlets when we're applying manure and nutrients. There are some better options for draining closed depressions other than those regular surface inlets, the good old orange chicken bottom riser. What you see here is called a blind inlet. It works kind of like the reverse of your septic drain field. The perforated PVC pipe is set in gravel, which rapidly moves water from the surface into the tile. This is then covered up with 2 feet of soil, which helps to filter out sediment and nutrients. And these can actually be farmed right over. A simpler, although less effective retrofit is called a water quality inlet. These green straws slow down the water flow slightly enough to allow soil to settle out before it reaches the inlet. When it comes to nutrient management, we should always be using best management practices for fertilizer and manure applications. Follow 82809 and the SNAP Plus guidelines. Nitrogen is especially prone to leaching through tiles, and so any way you can fine-tune your nitrogen management is a good way to minimize losses. The closer you are to putting on only as much nitrogen as that crop needs and not anymore, the less nitrogen is going to be available to leach down through the tiles. When it comes to fall manure applications, if you're not applying manure to a growing plant like a cover crop, you need to wait until soil temperatures have fallen below 50 degrees. If you can't wait that long, a nitrification inhibitor can buy you 2 or 3 weeks of time so that ammonia isn't converted into nitrate. But cover crops are a very effective way at reducing that nitrogen loss. Use conservation management practices such as cover crops, conservation tillage, and grass waterways. Reducing soil erosion is important to stopping soil movement, and cover crops can capture soil nitrogen that would otherwise be lost. Anytime you're stopping soil and nutrient movement on the surface, that is actually helping to reduce losses to the tiles as well. Mentioned nitrogen a few times. Nitrogen is the most easily lost nutrient that moves through the tile. 3 times more nitrogen is lost through tiles than is lost through surface runoff. And of the nitrogen that's being lost in the tiles, 92% of it is lost in the plant available nitrate form. Nitrate's not held by the soil, and so anytime we have water moving, we have nitrate moving. Cover crops are very effective at reducing nitrate losses to tile. This study from Iowa, among many others, shows an approximate nitrogen reduction of 50% when utilizing fall cover crops. The big caveat with cover crops is that they need to be established early enough so that you have decent growth in order to capture those nutrients. Don't put your fall manure on and then plant the cover crops. Put the covers on first. Don't expect to hold any nitrogen if all you're doing is drilling cereal rye on November 1st. The drill should be chasing the chopper. You need to get those covers on early so that they're large enough to capture those nutrients. Finally, if the worst does happen and you do have manure flowing through the tiles, you need to have an emergency plan in place. You can try plugging the outlet. You can break into the tile with an excavator and dig a pit to pump the manure out of. Create a berm with some hay bales or dirt. You need to do something. You won't be able to do any of these things quickly if you haven't thought about how to do it ahead of time. And of course, if you do have a spill, call the DNR spills hotline immediately. I think our DNR friends will be speaking more about this topic after me. So proper nutrient management is the key to reducing losses on tile lands. Proactive management, that's the key. It's much less expensive and more effective to prevent manure nutrient losses than treatment. There's a variety of tile treatment systems that are being proposed, denitrifying bioreactors or saturated buffers or engineered wetlands. All these things have varying levels of effectiveness, but they're all more expensive and actually take up farmland. And so if we keep the nutrients and manure out of the tile to begin with, don't have to spend money and give up resources trying to capture it at the back end. So remember that the soil surface and tile drains are closely connected. And so what gets applied to the soil surface potentially finds its way down to the tile. And so we need to take extra care in managing manure on tiled lands. We want Goldilocks conditions in terms of soil moisture and precipitation. Soils can't be bone dry, but we also don't want them wet at all. And we need to make sure that precipitation is at least 2 days, preferably 3 days or more in the future before we apply manure. And also we need to adjust manure rates accordingly. Like I said before, low rates are lower risk than high rates. I want to give you a quick update on our current tile research. Wisconsin and Minnesota Discovery Farms, we're in year 2 of a 3-year tile study to better understand how to properly manage manure and nutrients in tile systems. We're also working with Dr. Matt Ruark and Dr. Francisco Arriaga's labs in Madison to understand if there is a relationship between soil health and tile drainage. Do healthier soils lead to cleaner tile water? So we're monitoring sites in 4 counties in Minnesota and 4 in Wisconsin. In Wisconsin, we're on Shawano, Brown, Kewaunee, and Lower Door, and Manitowoc counties. So between those 2 states, we have 24 sites in each state, so we have 48 total sites that are part of this project. In every county in the study, we have one of these intensive sites with our automated 24-hour, 365-day-a-year monitoring, keeping track of all the water that flows through and taking automated water samples to check for soil and nutrient concentrations. Nearby, we have 2 or 3 of these intermediate sites where we have continuous flow monitoring, but no automated sampling. We come out every 2 weeks and take water samples out of these to check for nutrient and soil concentrations. We also have 2 or 3 of these basic sites, which is quite literally we just go to the end of the pipe and take a flow measurement and a water sample every other week. We're trying to utilize these lower level monitoring systems to try to get more data more cost effectively by pairing it with the flow information that we're getting from those intermediate and intensive sites. Here's a quick preview of some of the data that we're seeing so far. The median soil loss and phosphorus loss for Wisconsin and Minnesota are about the same, but Wisconsin has a lot more variability. I think that has to do with some of our variations in tile systems and materials, as well as our high phosphorus levels in the soils in Wisconsin and our widespread use of manure. The one that really sticks out on the negative for Minnesota is the nitrate losses. They have pretty high nitrate losses compared to Wisconsin. I think a lot of that is because they're using cash grain systems, and some of those farms are actually even still using fall anhydrous ammonia, which is quite easily lost to tiles. Here's a quick look at some of the flow frequency of the tiles that we've been monitoring. Some of those tiles have never stopped flowing, and a couple of them hardly ever flow. And so there's a great diversity in the consistency of how and when these tiles are flowing. So if you have more questions and you're looking for information about tile drainage, you can visit our fyi.uwx.edu/drainage page. You can also go to uwdiscoveryfarms.org. We have a variety of publications on tile drainage. And if you have real specific questions, feel free to reach out to me. You got my email and phone number there, and I'd be happy to answer any questions. So thank you for your time, and guys have a great day.